HazLoc, an introduction and classification. The topic of HazLoc relies heavily on the information provided in Section 18 of the Canadian Electrical Code. There will be multiple references to rules within this section, as well as Appendix B within this presentation. In this presentation, we're going to be looking at what is HazLoc, the classification of HazLoc locations, and the classification of gas and dust within HazLoc. HazLoc is really shorthand for hazardous locations, and these are electrical installations where gas, dust, or fibers pose the threat of explosion or fire. They come in many different forms. Even dusts that we assume are non-hazardous to begin with, if they are blown up into the air and become of very small concentrations in clouds of air or dust, they become extremely flammable. Even things such as grain, sugar, and non-dairy coffee whitener. Even sawmills have the possibility of absolute catastrophic damage, as we saw in 2012 in the province of BC. Dust has the added problem of having an initial explosion, which may have been caused by dust or something else, but the blast wave of that primary explosion then causes dust that is settled in the area to become airborne, and at this point, a secondary, much more powerful explosion takes place. Fibers and flags are also an item of consideration, however, not nearly as hazardous. They still have a place within HazLoc and Section 18 of the Canadian Electrical Code. The one which most people are most aware of is gases. Gases are obviously explosive and flammable depending on what type and their concentration. Some are lighter than air, some are heavier than air. They can be gasoline that's in a liquid form or items that are in a gas form like natural gas or any other type of petrochemical. Gases can be seen at mobile drilling applications as well as permanent industrial facilities where we're manufacturing different types of plastics or refining items. Gases are also present in mining applications. As an example of the detrimental effects of a gasoline or gas type explosion, we're going to look at an acetylene explosion in Australia. This is a plumber's van who had an acetylene brazing tank that was leaking. The doors were closed, the van then filled with gas, and when they used the auto door lock feature, it exploded. Well, let's see what it looks like. Ooh, not so good. Hope he had good insurance. That's a portion of his van on the other side of the cul-de-sac, and there's the van itself. Back of the van, side of the van, overhead view of the van, and you can see here is where he was parked in front of his customer's house. Van overhead, shot of the neighborhood, front of boat, that would be his customer's boat right there, and rear side van panel, that would be located here originally. And then the neighbors on the other side, part of the roof rack and the passenger side door, and there's the van again. Historically, there have been two methods of classification that have been used for HazLoc. The class and division system is the earlier, more primitive system. It's older, it was used in pre-1997 in Canada, and only had two separate gas classifications. It was mostly used in North America and sometimes referred to as the NEC classification method. On the other side, we have the zone classification method. It's newer, it was adopted by Canada after 1997, and it has three gas classifications. It's used internationally and sometimes referred to as the IEC classification method. Now, Canada and the Canadian Electrical Code have adopted this form of classification to determine the degree of hazard for different hazardous locations. If we take a look at 18004, classification of hazardous locations, it states that the hazardous location will be divided into either an explosive gas or an explosive dust atmosphere. And then further on, it says an individual who is qualified will carry out the necessary testing and evaluation to determine how hazardous it is. Now, this is not the electrician. This is typically a process engineer. If we look in special terminology, we can see what the different types of classifications will be. The zone system, as it seems from its name, is divided into 6 different zones. 3 of them are gas, 3 are going to be dust related. What you will notice is that they get more or less and less hazardous as we go increasing in numbers. Zone 0 is where we have explosive gas that's present continuously. Zone 1 is explosive gas likely to occur in normal operation, or something right beside Zone 0. And Zone 2 is that an explosive gas atmosphere is not likely to occur in normal operation, but if it did, it would be for a short time only. Or it could be a location beside a Zone 1. When we look at dust, dust is going to have, again, 3 different classifications, one of which is missing here, but you can find in 18002, the missing item, we have Zone 20, Zone 21, and Zone 22. Zone 20, 21, 22 are, again, allocating the degree of hazard based on what type of dust and how often it's going to be present in the air. If we look at all 6 of them side by side, we can see 0 to 2, hazard not likely to occur in normal operation, hazard present continuously, and hazard not likely to occur during normal operation yet again. Now, there is a different form of classification, but in the main body of the code, it is not provided for. That is the class and division system. Class and division has 3 different classifications, and each classification is then divided into 2 divisions. You'll notice that there are only 2 gas divisions, 2 dust divisions, and then they divide up fibers and flyings into yet another 2. Now, don't worry, you're not going to have to take down notes on this particular portion because I'll be showing you later in the presentation where we can find this information in the Canadian Electrical Codebook. Now, why was zone classification adopted over class and division? Well, electrical equipment installed in the most hazardous locations must not cause an explosion, and therefore it's highly engineered and exceedingly expensive. As an example, we could take a look at a gas station filling area where we fill up with gasoline, and if it was classified using the class and division method, the areas shaded black would require the most expensive HazLoc equipment available. So that's quite a substantial amount of the overall installation that would require this. Whereas if we take the exact same gas station filling with the zone system, there is only a small portion that requires this exceedingly expensive over-engineered apparatus. In Appendix B, we have Table B18.2, which provides some information on the equivalency between the zone and the division area classifications. And we have all 6 of the zone, and then we have all of our class and div shown on the other side here. So how does the Canadian Electrical Code deal with these 2 classification systems? I mean, if Canada's adopted the zone system, why on earth are you showing me the division system? Well, if we take a look at 18000, the scope of Section 18, it states the section applies to location where it's going to be subject to the following classifications. And if we go down a little bit, it adds that for additions, modifications, or renovations, or operation, maintenance of existing facilities employing the division system of classification, they can continue to use the division system of classification. Otherwise, what the manufacturer would need to do is have a full engineering study done on any additional renovation and then convert that to zone and use different equipment. It becomes a massive headache and a massive catastrophic waste of time and money. So it states here to help facilitate that in Subrule 4 that if we are using the division system of classification, we are permitted to continue with it, and the rules for the class 1 and 2 locations are found in Appendix J of the Canadian Electrical Code. So Appendix J provides an entire archived portion of the older class and division type of classification for HazLoc installations. We even have a little citation here in Appendix B, and it indicates that Yes, zone and division systems are deemed to provide equivalent levels of safety. However, it says the code has been given preference to the zone system. It's important to understand that while the code gives preference to the zone, it does not give preference to that type of equipment. We're going to look at the IEC type of equipment in the next presentation. It states equipment marked for use with this old style class and div is acceptable to be used in our zone areas. And we'll see that there's going to be different tables and resources that we can reference in order to determine exactly what is permitted. Here's a little excerpt from Appendix J, providing some of the classification and division of those different older style of classifications. Remember, you don't have to memorize all of these as long as you know where you can find them within the Canadian Electrical Code. Explosive gases are divided into hazard categories based on their volatility and ignition temperature. If we take a look at 18050, this is the initial rule that will start indicating what is required for markings on equipment. Before we get to the actual markings of equipment, though, we need to know how gases and dusts are going to be divided. We can see here that gases are divided into groups, and the groups are based on their volatility and how readily they will ignite. They list a portion of them, but there's very little detail of information on each gas. Appendix B is then used if we need further details on this information, which we will when we're looking at enclosure and equipment ratings. Appendix B, Table B18.3 provides temperature and gas groupings. It goes on for about 4 or 5 pages, and the one column that's of the most interest and use to us will be the auto ignition temperature column. A quick reference table provides details on both the zone and the division gas groupings. Table 18A. So even though we have zone groupings for gases, there is going to be simply basic letter groupings for gases in the division system. Everything is replicated in division, in the division system rather. Explosive dusts are divided into hazard categories based on their size and conductivity. So if we look at 18002 special terminology, dust is a generic term that's then further divided into combustible dust, conductive dust, non-conductive dust, and combustible flyings, which have a size no greater rather than 500 micrometers. Grab your measuring tape. If we take a look at 18050 again, Subrule 6 indicates that equipment with a type protection permitted in the dust zones is suitable for group 3C, 3B, and 3A. So for IEC, or the zone selection or classification of dusts, we have group 3A, B, and C, indicating 3C is metal dust, 3B is combustible dust other than combustible metal, and 3A is these greater than 500 micrometers. Again, Table 18A will provide equivalent zone and division group classifications for dusts as well. You'll notice down here, they are Group E, Group F, and G.